Hello everyone. Today we're going to be discussing the Pythagorean Theorem. Now, the Pythagorean Theorem, as I have a picture of it here, is a squared plus b squared equals c squared, okay? A being a leg, b being a leg, c being the hypotenuse. Just going to write it like that. Okay? Now again, the triangle could be flipped the other way. It's still AB. Where A is and where B is doesn't necessarily matter, okay? Let me fix this here. Okay, so let's say we're on a graph. We are on a graph, technically. This could be, this point here could be, I don't know, X, Y, Z. Okay? Again, that's line segment XY, or that's line XY, and then line YZ, and then the hypotenuse is XZ. Okay? So what we're going to do is we are going to find the sides of the hypotenuse. Okay, so I'm just going to put in some random numbers, okay? Let's say, also, side note, if you don't have the length from here, let's say from X to Y, you don't know what A is, you don't know what B is, you don't know what C is. What you could do is you could use the distance formula, which we have covered already. So I'll write that down. You could use the distance formula, and I have another video on that, and you could just get the distance from X to Y, and then the distance from Y to Z, and then the distance from X to Z, or vice versa, from Z to X. But in this case, we're going to assume we already have some of the distances, and we need to find C, the distance from X to Z. Okay, so I'm just going to make up some points, or some values, I should say. A is 5. Let's say B is 9. And we need to find C. Okay, so we're going to go ahead and plug it into our formula, which we have right here, the Pythagorean Theorem. And I always like to write the formula of the theorem first. A squared plus B squared equals C squared. Okay, so we know that we have A is 5 squared plus 9 squared equals C squared. Okay? 5 squared is 5 times 5, which is 25. Plus 9 squared is 9 times 9, which is 81. Equals C squared. Okay? So 25 plus 81, I have no idea. 106, I think. Okay? So we have 106 equals C squared. So now in order to solve for C, we have to take the square root. Square root, square root. Now a common mistake that students make is when the square root of a number squared, this cancels right here. So you're just left with C, okay? And the square root of 106, this is not a perfect square. So we're going to leave it right now. Square root of 106. But we can approximate this value, okay? So I'm going to check it really quick. So I have that C is approximately, because when you use your calculator, it's an approximation, 10.29. let's just round up. C is approximate 10.3. Okay? There's our value right there. So that means C is 10.3. Okay, so C equals 10.3. And that's it. That's our value there. We're done. We know all the sides of the length of the leg, and hypotenuse. Okay? But I'm going to do another example really quick. And I'm going to do nice numbers, okay? Because that was not too good. 3 and 4. Okay, we need to find the hypotenuse. So, we're just going to call this, and I'll use different color. We'll call this A, B, C. A is 3, B is 4, C, we have no idea. Let's go ahead and use the formula. A squared plus B squared equals C squared. All right, let's plug them in. 3 squared plus 4 squared equals C squared. 3 times 3 is 9, plus 4 times 4 is 16, equals C squared. 9 plus 16 is 25, equals C squared. And just like before, we're going to take the square root of both sides. Square root, square root. And remember what I told you? That these will cancel. So what's the square root of 25? If you don't know what that means, what number times itself will give us 25? And that's 5. So square root of 25 is 5 equals C. And I like to write it the other way. C equals 5. Nice number. I'll just put it there. So now we know the value of the hypotenuse. We know it's 5. Okay? So again, this is the Pythagorean Theorem. Hopefully this was clear. And if you have any further questions, please don't hesitate to ask, all right? See you guys later. Peace.